Okay, let's talk about the correctness of parallel linked data structure operations. And this discussion follows the discussion in the Solihin text, Chapter 5. The criterion that we want to ensure is serializability. A parallel execution of a group of operations is said to be serializable if there's some sequence of operations that produce an identical result. So what we want to assure is that the operations that go on in parallel do the exact same thing as some sequence of operations that could be executed sequentially. So this is a general rule for a parallel program. If it is to give the correct result, it's got to give the result that would be given by a serial execution of the same program. Let's take a couple of examples, or an example here. Suppose that a node insertion I1 and a deletion D1 are performed in parallel. The outcome must be equivalent to either the first operation followed by the second, or the second operation followed by the first. If it's not one of those, then it's wrong. Let's consider now a conflict between two insertions. There's a little diagram that shows this over on the right-hand side of the page. And this, actually, the diagram's on the left-hand side of the page, and it shows that thread 0 wants to insert 4, a node containing 4, and it wants to insert it right after node 3, whereas thread 1 wants to insert a node containing 5, and it wants to insert it right after 3. So let's say both of these threads get working at the same time. In this case, they both allocate their new nodes, and then they set the next pointer from these nodes to point on to node 6. Now suppose that the first thread to set the next pointer from a previous node is thread 0. So it sets the next pointer from node 3 to point to node 4. And before the program goes ahead, node 5 gets linked onto the list, and it gets linked because the next pointer of node 3 is set to point to node 5, and the next pointer of node 5 is set to point to node 6. The fact that node 4 also is pointed at node 6 doesn't matter because there's no way to get to node 4. Therefore, the insertion has been lost. Okay, now let's look at an insertion and a deletion. In this case, we have node 3 is linked to node 5 is linked to node 6. Thread 0 wants to put 4 on this list, while thread 1 wants to take 5 off of the list. So what would the serializable outcomes be in this case? Well, they'd be one operation followed by the other operation. That is to say, insert node 4 and delete node 5. That's okay if we have the operations occur in that order. Or delete node 5 and then insert node 4. In any case, the nodes on the list at the end of this execution are going to be 3, 4, and 6. Node 4 is in the list, but node 5 is not on the list. And you can see how node 4 could be lost in this circumstance. Node 4 gets linked onto the list in this step, but then in the very next step, another thread has picked up the next pointer of 3, and it used to be pointing to 5, so it wanted to delete node 5. It set it to point to the next item on the list, which is node 6. Unfortunately, by bypassing node 5, it also bypasses node 4, which was linked to node 5. And both of those items are removed from the list, so the insertion of node 4 has been lost. Okay, so in order for it to be correct, node 4 has to wind up on the list, and node 5 has to wind up off the list. The next potential kind of conflict is between an insertion and a search. Here we're trying to insert node 5 and then look for node 6. So we could either insert node 5 and look for node 6, or look for node 6 and insert 5. Doesn't matter which operation gets started first. In both of the cases, at the end of the execution, node 5 must be on the list, and node 6 must also be on the list because it's going to be found there. So here are two possible sequences that could occur. The first one is that node 5 is put on the list, but the pointer from node 3 to node 5 is not inserted until after the search operation follows the pointer from 3 to 6. Then it does find 6 on the list. In this case, though, The first thing that happens is that node 3 is set to point to the new node, node 5, and then the other thread comes along and tries to do a search. So instead of getting onto node 6, it'll get onto node 5, and it might even try to follow this as yet null pointer here, and then it would just find that it had reached the end of the list. And meanwhile, the other thread is working on linking this pointer here to point to that node, but it didn't get there in time, and so the other thread didn't find 6 as being on the list. That's a situation there where an uninitialized link may be followed. The next situation is conflict between a deletion and a search. The first thing we want to do, the first thread or the 0th thread, deletes 5, then searches for 5. And then suppose that one thread deletes 5 while another thread is searching for 5, or that the first thread or the 0th thread is searching for 5 while the other thread is deleting 5. In this case, there are a couple of possible outcomes. Node 5 may or may not be found, depending upon whether the deletion happens before it's found. And then the other possibility, actually which should happen, is that node 5 is deleted from the list. So let's look at the way this takes place. We start out with a list 3, 5, 6. The first thing we try to do is to delete node 5 from the list. We set the next pointer from node 3 to point directly to node 6, and then we come on in and with the other thread set the next pointer or follow the next pointer of 3 that points to 6, thereby bypassing 5, so 5 is not found on the list. What, if anything, is the problem with these outcomes? Well, it doesn't really matter. I mean, these outcomes are not wrong. If somebody's trying to delete a node while another thread is looking for the node, then we don't have any clear right behavior. We might find the node or we might not find the node. Either one is a correct behavior because it could have happened in a serial program. So either way is okay. So a deletion and a search don't really conflict. Let's summarize what we found. Parallel execution of two operations that affect the same node, in which at least one of the operations involves some change to the node, writing to the node. They can produce conflicts that lead to a non-serializable outcome, but they don't necessarily produce a non-serializable outcome. If we're lucky about the ordering in which the operations execute, then we might still achieve a serializable outcome. It's also possible for conflicts to occur between linked data structure operations and memory management functions such as allocation or deallocation, and we really haven't considered those. I guess we've considered deleting nodes at the same time that other things are going on. So there are the basic building blocks for parallel operations, and next we're going to go and take a look at how this can be implemented in parallel.